Welcome second graders to the Dallas Independent School District STEM Environmental Education Center. We'd like to give a special welcome to a number of schools who are with us this afternoon. We have students from W.A. Blair, Victor H. Hexter, Jose Joe May, Herbert Marcus, George H.W. Bush, Eduardo Mata, M.T. Riley, Arthur Kramer, George W. Truitt, Anne Frank, Trinity Heights Tag, Frederick Douglass, Casa View, and Leslie A. Stemmons, all with us this afternoon. Thank you so much for joining us. We wish you could be here in person, but since you can't be, we're going to do our best to make you feel like you're here during a virtual field trip program today. If you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/pk-2 registration to get yourself or your class registered for this field trip. And we just use that information for our attendance purposes. And this afternoon's program is titled Forms of Energy. During this virtual field trip, students will investigate the effects on objects by increasing or decreasing amounts of light, heat, and sound energy. So we're going to start things off this afternoon with an introduction to energy by Ms. Schramm. Next, we're going to explore light energy with Mr. Monroe. Third, we will explore thermal energy with Mr. Ramirez. And last but not least, we will explore sound energy with Mr. Dominguez. While we're doing all of that, we encourage you to ask questions, but since this is a virtual field trip, the way you need to ask a question is go to www.tiny.cc/question-answer and fill out a really short form to submit any question you have related to forms of energy to us. You can ask as many questions as you like, and we'll do our best to answer all of them in the time that we have with you this afternoon. So let me stop sharing my screen here and turn things over to Ms. Schramm, who will get us started with that introduction to energy.
Hey everybody, it's Ms. Schramm. And like Mr. Bratton said, I'm going to do the intro to energy. And we're going to talk a little bit about different forms before I send you off to the other teachers. So before we get started, let's define energy. So what is energy? Energy is the ability to do work. Energy is what allows us to move, to run, to jump, and to play. And here are so many different forms of energy. There's gravitational, sound, chemical, thermal, nuclear, potential, kinetic, solar, light, electrical, and mechanical. But who uses energy? Well, plants use energy. They get energy from the sun and nutrients from the soil to grow. Animals get their energy and nutrients from the food they eat. So we are animals too. So we get our energy from our foods as well. So I want to introduce you to a new friend of mine. And he is very cute. He's fluffy. He uses his energy to run, to hop, and to jump. All right, so think about who he might be while I scoop him up. And this is a new bunny named Apricot. So Apricot is only a few months old, I think. He's pretty little, but he gets his energy from eating very healthy foods. He eats, Apricot. He eats lettuce and spinach and lots of fruits and veggies. And all those leafy greens give him tons of energy so he can play all day with his little bunny brothers and sisters that we have out here at the center. So I'm going to put little Apricot away because otherwise I will get distracted. All right. Thank you, Apricot. That was his debut. Okay, so first we're going to talk about kinetic and potential energy. And let's see. So I have this little diagram, and here's our little friend Sally. She's standing at the top of a ledge, and she's holding a ball in front of her. The ball is not moving, so it has potential energy. That means it has the possibility of moving, right? So she's holding onto it tight. It has potential energy. Once she lets go, that potential energy doesn't go away. It gets turned into kinetic energy because that force of gravity starts pulling the ball towards the earth. So potential is staying still and kinetic is moving. Here's another example of a car going up a hill. So as the car is going up, it takes a lot of energy to get there. So it's putting a lot of energy in. When it gets to the top of the hill, it has potential energy. Then as they let go of the brakes, gravity pulls it towards the earth, and that potential energy is transferred to kinetic. Now, when you combine potential plus kinetic, you get mechanical energy. So just like when you hammer a nail, when you lift up the hammer, you have potential energy. When you bring the hammer down, you have kinetic energy. And then the nail going in the wood is mechanical energy. So let me see. And then I want to show you one more example before we do our real life experiments, okay? So another way that you can see mechanical energy is through a water mill, and we'll try this out too. So if you add the potential energy of the water falling down, the flowing water, and then once the water starts flowing and falling, that's the kinetic part. So sorry, the water at the top is potential. Once it starts falling is kinetic. And once it starts turning that wheel, it is mechanical. All right, so let's stop this little sharing and I will show you what I'm talking about. So first I'm going to try the hammer and the nail. So I spilled a little bit. Okay, here we go. So I've got a little piece of wood and a teensy tiny nail, and I'm going to put it on the wood and hold it tight. Then I've got my hammer. So I'm going to lift the hammer up, giving it potential energy. When I lower it, kinetic. And when the nail goes into the wood, that is mechanical. Ready, spaghettis? Boom. So it took that, let me see, there you go. So it took that potential energy and kinetic to make that nail go into the wood. All right, let's try our other example. I'm gonna take my little Tupperware lid and a little cup. And I've got our friend Sally, and she is going to be riding in her car. So this is gonna show us potential energy when she's at the top of the hill, just like that little graph. When I let her go, gravity is going to act on her car and pull her towards the earth. So that'll make her move and her wheels will turn, giving her mechanical energy. Okay, so ready, spaghetti, go. And there she goes. All right, let's see. My other example I wanted to show you was the little water wheel. So just like that water wheel I showed you in the diagram, this water wheel is like the ones we have in real life. So let's see, the little wheel goes here, and then there needs to be water flow on top, right? That running water. So as I'm holding the water up, just like in that diagram, it is not moving yet, so it's potential. Once the water starts flowing down, it's going to have kinetic energy. When it hits the little blades on the wheel, that is going to make mechanical energy because it's going to make that wheel turn. So let's go ahead and see. And I'm sure you guys have played with these before. They're like little beach toys, but it works just like the big water wheels too, turning that little gear. All right, so hopefully you learned a little bit about energy. I'm going to send you off to the other teachers, and they're going to teach you a lot more about light, sound, and thermal energy. All right, I'm going to have Apricot say goodbye, and hope to see you next time.
Thank you, Ms. Schramm. Taylor from Hexter Elementary asked, what kind of energy do we use? We use light energy to see, sound energy to hear, thermal energy to stay warm and cook our food, electrical energy to power things that need electricity, solar energy to grow plants, mechanical energy to move and build other things that can move like wheels. And so we use energy in lots of different forms of energy, lots of different ways every day. So now we're going to go a little deeper into light energy with Mr. Monroe.
Good afternoon, students. My name is Mr. Monroe. And of course, you guys can see me right now, right? Well, if I was to turn all the lights off in this lab, do you think you would be able to see me then? I doubt it, because we would have a very low amount of what we call light energy. Light energy helps us to see. We're going to do a little investigation, or we're going to look into what we call light energy. What is light? Well, whenever we ask that question, most of the time the answer is, well, we see light as being bright, or maybe even bringing the fact that we see colors because of light. And that's correct. What light is, it's actually an electromagnetic radiation, partly electric, partly magnetic. Believe it or not, this whole room right here is filled with light energy, but light energy travels in straight lines. I want you guys to remember that. Now I'm going to show you a short presentation. At the end of that presentation, I'm going to show you a couple of light sources. We're going to talk about how light energy kind of behaves in certain conditions. Those conditions exist around us, and we'll go from there. So bear with me while I share my screen with you for that short presentation. It's going to take a little bit to load, and we will get started. Learning about light, it's so very important to us. And it is science that we're studying today, right? So we're talking about light energy. Now, without light energy, could we see? Probably not. How we see depends on the light energy that is surrounding us. Now, as we go through this presentation, we're going to learn where light energy actually comes from. There's two types of sources. One is referred to as a natural source of light energy. The other is what we call artificial or man-made light sources of light energy. So let's get started. Light seems to be all around us, whether it's dim, whether it's just a very little bit of light. So where does it come from? Well, those sources are all around us. And even today, we have a lot more man-made light sources than one would ever think of. But let's start out by talking about those that we know about. And I bet you guys have some around you right now. But the most important light source that exists in our lives today, the most important, is the sun. We get a lot of light energy from the sun. Can you imagine this world without us getting light energy from the sun? Probably not. Life as we know it could not and would not exist on our planet. Living things need sunlight. Sunlight keeps a lot of the cycles going that exist on our planet, that keeps everything going. So that is a major source of light energy that exists for us to stay alive here on the planet Earth, for everything to stay alive. So how about this candle in the image? Of course, we know that the candle is man-made. The little flame at the top, well, believe it or not, fire is considered to be another form of natural light energy. Okay, I want you to remember that. On the other hand, a light bulb, such as this image, the next image, that actually is a man-made source of light energy. We know that man manufactures the light bulb, and it's ran off of an electrical energy source that provides, I guess the filament inside the light bulb is heated up to such an intense heat that it gives off a glow, providing light energy for us to be able to see. What about some reflectors of light? You know, when I was your age, a lot of things that I observed, guess what? They were not actually light sources or sources of light energy. You know, there are things that look like they have their own light source, but they are actually reflecting light from another source. Take, for example, the night sky. Of course, if you were to look up in the night sky, you would see stars. Now, those stars, guess what? They are a form of natural sources of light energy. Because guess what? Our sun is just another star. And it indeed is a natural source for light energy. So, how does light travel from a light source? Well, a perfect example would be one object that when I used to look at the night sky and I would see those stars, I would often wait and be excited when I saw the full moon. And when I saw that full moon, looking how bright it was, I always thought that that bright moon was making its own light. Boy, was I wrong. Simply because later I found out that the moon is actually using the sun's reflected light energy to give us the appearance that it has its own light. So that's a case of reflection, light reflection. How does light help us to see? Light is a type of energy known as electromagnetic radiation. And this radiation, it's made up of photons, little particles of energy. Now, these particles are very tiny. And you know what? They don't have any mass, and they're not really made up of matter. They are just tiny particles of energy. So they don't weigh anything. They don't take up any space, okay? Light travels as a wave, but unlike waves of water or sound waves, it does not need any medium to travel through. Doesn't have to go through anything to exist, or even it can travel through a vacuum. And when we're talking about a vacuum, we're talking about an empty space, a completely airless space it can travel through. Light waves travel out from sources of light in straight lines. These lines are often called rays or beams of light. Take, for example, this image. We have a chair, and you have a young lady, and over in one corner, we have a light bulb. The light source is going to provide light energy that is going to be bounced off of that chair into the eyes of the young lady. Reflected. Now, I'm standing in my lab, and I have a lot of stuff in this lab. Right now, I've got a little experiment going on one table. On another table, I've got some activity material that's coming up for the lessons next week. And at the back of our room, there's a lot of animals. I've got a large aquarium with a big snapping turtle. I wish you guys were here so you could see those things. But I can see all of that. But if I was to step over and turn that light switch down, which would turn the light source off, I would not be able to see a lot of the objects that I'm looking at, simply because light energy would not be able to bounce off those objects. Now, I'm going to stop sharing my screen with you guys, and we're going to get into looking at some good examples, okay? So, particles of energy, light energy, okay? Those little particles are called photons, okay? Remember that. Now, you know, there are a variety of light sources that we use in our everyday lives. We use things such as a lamp. I've got a lamp that has a little shade on it. And that reminds me that there are some materials, some matter, that light cannot go through. See, if I take this shade off, that light becomes very, very bright. That means the waves or the particles of light energy are shooting away from this light bulb, going all over this place. Remember, it's traveling in straight lines. If I put the shade over, it's cutting down some of the light energy that would be dispersed or moved all over the area where it once was, okay? Now, remember when we were talking about the moon, how there was a reflection from the sun's light energy that created the moon's image of having its own light? Well, anything smooth, like metal or anything shiny, you know what? That will happen to those if a light energy ray or beam hits that. I've got my little mini mite flashlight here. It's very powerful. And I've got a mirror here. And you know what? I bet I can give you the impression that this mirror is lit up by reflecting some light from this flashlight. Let's see what happens. Yeah, let's see if I can get the right angle. There we go. It almost gives you, let me turn that lamp on. I think that's hurting us a little bit. Let me get that right in there. There we go. Almost gives you the impression that the mirror actually has a light, and it doesn't. It's reusing the reflection of the light energy from this flashlight, and that's called reflection. The other type of behavior that light can have because of matter, interacting with matter, is the fact that you have two clear objects, transparent, meaning that you can see through them, and light is dispersed through it. Remember, light travels in a straight line. This straw is straight, isn't it? You guys see that? If I put it in this container here and it comes to rest, you can see that at some point it seems like the straw is broken. Right at the top here, if you look, the bottom part that's in the water seems like it's been disjointed from the top part. That's because the light energy that's surrounding this container is going through the transparent, meaning clear objects here, and it's being bent. It's being refracted. We call that refraction. And then, just like the shade, guys, listen, it was only letting so much light through. There are some parts of matter or some things that are made up of matter that will not let light pass through it. My hand probably won't, and you guys could probably have fun doing this, but I like to make a bunny rabbit because I know that the light energy is not going to pass through my hand. So if I shake my hand like this, I can give the impression that I have a bunny rabbit. See its ears? Yeah. And then I've got a little animal friend here I want to show you guys. I've always been curious about this little animal, what kind of shadow it would make, because I know that light energy can't penetrate through it. This is Hoppy Jr. If I had Hoppy Sr. up here, he would be a lot bigger. This is a young bullfrog. And of course, if you look at him, you can see he's got a little color to him, got some spots. But do you think light's going to pass through him? Let's see what happens. Oh, it doesn't pass through him or my hand, but you can see the shape of the frog, can't you? Look at his eyes. You can see the little bumps on top of his eyes, but you can't really see his eyeball. And you can see his hands and his webbed feet. That is a shadow. Anything that light cannot penetrate on the back side of that, if there's a light area, then it's going to cast what? A shadow. So different materials, clear, transparent, will let light penetrate, but there is matter that will not let it come through. So students, listen. Hopefully I've helped you learn a little bit about light energy. I want you to remember, it's the energy that helps us to see. And one more question I want you to research. Would you consider fireworks going off in the sky? Would you consider that a form of natural light energy, or would you consider that to be man-made? Now remember the candle, even though the candle was made out of man-made materials or man-made that, but the fire part, what do we consider it to be? A natural source of light energy. You guys have a good day. I've used up all my time. Hopefully you'll enjoy the rest of your virtual field trip. I'm going to turn it back over to Mr. Broughton. So you guys have a good day. I bet he can answer your questions if you have any.
Thank you, Mr. Monroe. There were some questions. Alex asked, how do fireflies make bioluminescence? That is a tough one. And luckily I have Google to help me. Fireflies produce a chemical reaction inside their bodies that allows them to light up. And that type of light production is called bioluminescence. But what I thought was interesting is, unlike a light bulb, which produces a lot of heat in addition to light, a firefly's light is cold light. So they don't lose a lot of energy as heat. And that's necessary because if a firefly's light producing organ got as hot as a light bulb, the firefly could not survive. So they do produce a light called bioluminescence, but it's a cold light, so it's different than a light bulb. And then we had some questions from Miss Garner's class. What would happen if sound energy is used with heat energy? And that Henry asked that, and sound energy is used with heat energy. One example I can think of off the top of my head is I just bought a new stove for my house. And if I want to bake a cake, I have to preheat the oven. And when that oven reaches a certain temperature, a little alarm goes off to let me know it's at the right temperature so I can put the cake in and not waste any time. Like sometimes with my old stove, I turn it on and it did not beep at me when it was ready. And I would forget about it, maybe spend 10 or 15 minutes doing something else and waste that energy. So that sound energy working with heat energy allows me to not waste energy at my house now. And I'll do one more and then we're gonna have to move on and I'll try to answer the rest at the end. But why does water spin the wheel? Catherine asked that. Water is matter, so it has mass, like weight to it, and it can push a wheel if it like flows into that wheel. Water can actually push lots of things if it's flowing into whatever's in its way. All right, now we are going to explore another kind of energy, which is thermal energy with Mr. Ramirez.
Hello, my name is Ms. Ramirez, and today we're going to be learning about thermal energy. And by the way, a special welcome to Casa View. I went there when I was in elementary school. So before we talk about thermal energy, I do have an animal friend that I want you guys to think about. I'm going to give you some clues to who this animal is, and then I'll let you guys guess. So my animal friend has 4 legs, a long tail, a beard of skin under his chin, and he also has spikes on his body. Now, he also depends on heat from the sun to keep his body nice and warm. So think about, what animal do you think this is? And I'm going to go ahead and pull him out. Again, he has 4 legs and a tail. And if you guys said a lizard, you would be correct. This is a type of lizard called a bearded dragon. He gets that name because he has a beard of skin under his chin. And when he gets mad or scared, he can inflate that beard really big to make himself look scary. He also has some spikes on his body. And because he's a reptile, we know that he needs heat from the sun to keep his body warm. Now, since he's inside, I have a heat lamp that's actually giving off heat. And I know that because I have a thermometer under here, and it is almost 90 degrees underneath that heat lamp. So it's rather warm. Now, since I said we're talking about thermal energy, let's figure out what exactly that is. So thermal energy is just the total kinetic energy of particles in a substance. Remember, kinetic energy is energy of motion. And we know that everything, you, me, everything in your classroom is made out of super tiny particles. Now, the faster those particles are moving, the more thermal energy they have. So for example, if my hands are cold, what is something I can do to make my hands warm? So you guys can go ahead and show me. And hopefully you guys are all rubbing your hands together, right? When we're rubbing our hands together, we are moving our hands. So that's the kinetic, the motion. And we're also generating that heat by friction. Friction is just rubbing things together. And that is one way I can make my hands warm. Now, another example of that is I have a bottle. Inside this bottle are beads. Remember I said everything is made out of particles? These beads represent particles. When the particles are moving, they have kinetic energy, energy of motion, and also when they move, they also have more thermal energy. An example of that would be if you guys are running outside, playing outside, you get hot and sweaty eventually, right? So that's your body releasing that heat as you guys are exercising. So what we're going to do next, we're going to take a look at how thermal energy relates to a thermometer. So a thermometer can tell us the temperature, and the way it works, there's a liquid inside It's usually red, but we know everything is made out of particles, right? So the liquid is also made out of particles. When the particles in this liquid get hot, they start moving around really fast. And because they're moving around really fast, it makes the liquid rise. And then during the nighttime, when it gets cooler, the particles start to slow down. They're going to shrink, and that shrinking causes the liquid to move back down. So that's how a thermometer works, based upon the movement of those little particles that make up that liquid. Now, to show you an example, I have what's called a hand boiler. That liquid is very similar to the liquid in a thermometer. So I'm going to use my body heat to warm the liquid up. Now, we have body heat. We know that because maybe in the morning you had your temperature checked with a thermometer to see if you had a high body temperature or fever. So I'm using my body heat to warm up the liquid. Heat from my warm hand is moving to the cooler bowl and causing the liquid to rise. And that is very similar to how a thermometer works. Hot things rise and cooler things sink or go down. The next thing I want to show you are just a couple of fun little things that I found at the store that relate to heat changes. So my first thing I have is something cool called Unicorn Barf, and it is color changing putty. So it changes color with heat. So notice the color that it is now. And I have my flame over here. Now, when we talk about heat, we always want to practice safety. So I'm using tongs. I'm not going to touch it. And if you're talking about heat in the kitchen, you probably use an oven mitt. And you probably have an adult with you, right? When you're messing around with something that's hot. So I'm going to heat up my putty. And the heat from the candle is going to cause a color change. It's also going to change the consistency of my putty. It's going to start to get all droopy and soft. So that's another change that heat can have on things. So I'm going to heat it up and we're going to see a color change. Now, the science word for things that change color with heat is called thermochromatic. So here we can see a color change. It's now a nice light blue. I also have some other cool color changing things. I have a color changing mood ring, and I also have some color changing nail polish. Now I know that if my nail polish is blue, that's letting me know that my body is warm. So look at the colors that you see now. I'm gonna put my hand in some ice water, so something colder. So let's see what the color changes. And hopefully you guys can see the color change. My fingernail polish is now kind of like a black color, and my ring also changed colors as well. So I thought that was something cool I found at the store. My next thing I want to show you guys is how heat affects things like ice. So you guys have probably done something like this at home. I have an ice cube. I'm going to put it over here on this little block, and we're going to watch how it changes as it gets heated up. So I have the ice. It was a solid piece of ice, right? When I add thermal energy to it, the heat from the air out in my room and the heat from this block is moving to the cooler ice, causing it to change states. It went from a solid to a liquid. It melted. So now I'm going to share my screen with you guys, and we're going to take a look at some examples of thermal energy here at the Environmental Center. So let me get that screen share started and we'll take a look. So we're going to be seeing how does increasing or decreasing thermal energy affect things. So here's my dog, Abby. Notice the dry, cracked ground. What do you think used to be here? And I'll give you guys a hint. It's been so hot lately that the sun caused this stuff to evaporate. So what do you think used to be there? And if you guys said water, you would be correct. So we used to have 2 ponds out here at our center, and it's been so hot that the heat from the sun caused the water to evaporate. It went from liquid water to a gas. So sadly, we don't have any water anymore in our ponds. And because there's no more water, all the fish and the snails that used to live in the water died. So Abby was rolling in thousands of dead snails. I thought that was pretty cool. Now here's a candle warmer. You guys might have one of these at home. They make your house smell nice and pretty. There's a bulb that is giving off heat, and that heat is going to affect this block of wax that you put on it. So I want you guys to think about, how is that block of wax going to change when we add heat to it? And hopefully you guys can see some phase changes. We had a solid piece of wax. When it got hot, it started to melt and it's turning to a liquid. And it actually took 46 minutes to turn from a solid to a liquid. Our next thing is, think about what happens when we decrease thermal energy of water. So here's water behind my house. What happens when that water gets super cold and the particles in that water start to slow down and they don't have a lot of thermal energy anymore? What change can we expect to see with that water? Hopefully you guys said it would freeze. So if y'all remember that weird polar vortex that we had in February when we had the snow and the ice and we didn't have to go to school for a week, water will freeze when it's 32 degrees below Fahrenheit. So that's really cold. So we know that temperature can actually affect our weather, and it also affects precipitation. So remember, precipitation is that stuff that falls from the sky, the rain, the snow, the sleet, and the hail. When it's super cold, below 32, we can get fun stuff like snow and ice that we had back in February. And that was just my two dogs enjoying that winter weather we had. And I have one last question for y'all, and that is, how does increasing or decreasing the thermal energy of objects affect them? And then try and give 2 examples. So I'm gonna stop my screen share, and that's all I have for you guys. We're gonna give it back to Mr. Broughton to answer any questions.
Thank you, Mr. Ramirez. Jack asked, what about fossil fuels? They make energy too, right? And that is correct. Fossil fuels do make energy. We can burn fossil fuels, which are coal, oil, or natural gas, to generate heat. And then we can use that heat to generate electricity, or sometimes just use the heat like from natural gas just to heat our homes. The problem with fossil fuels is that when you burn those, it pollutes the air though. So we're trying to find other ways to generate energy without burning fossil fuels. And then Arabelle asked, how much energy do we have as humans? That depends. If you get enough sleep, you're going to have more energy. But if you don't get enough sleep at night, you're going to have less. And if you eat healthy foods, you're going to have more energy. If you eat junk food, you'll have less energy. All right, let's move on to sound energy now with Mr. Dominguez.
Hi, friends. In this part of your virtual field trip, me and my friend Higgs, our very special guest, are going to talk about sound energy, and we're going to give you guys some examples of sound energy. En esta parte de su paseo virtual, vamos a hablar un poquito sobre la energía de sonido y les vamos a dar unos ejemplos de sonido. Y mi amigo Higgs nos va a ayudar un poquito con uno de sus ejemplos de sonido, ¿verdad, Higgs? So let's see what he can do, guys. Let's see what example he's going to show us. Can you guys guess what example of sound my friend Higgs is going to show you guys? Keep an ear out. We're about to start. All right, Higgs, do you want to show our friends some of your sound energy? First, I'm going to need you to sit down, okay? So sit. I need you to sit first. Good job. All right. Now, what I need you to do, Higgs, is first, let's give everybody a handshake. So you ready for a handshake? Give me a handshake, Higgs. Handshake? Good job, Higgs. Now, you ready for the sound energy? All right, sound energy. All right, Higgs. Speak, Higgs. What beautiful sound energy, Higgs. All right, guys. I think he deserves a treat for showing us an example of sound energy. All right, Higgs, you ready for your treat? Yeah, I think he's ready. All right, so let's give him a treat. Super excited. All right, here you go, Higgs. All right, guys, another neat way of showing how sound energy travels through the air is by setting up this pretty cool demonstration with some household items that you probably have at home. So what you're gonna need is a bowl. It doesn't have to be a glass bowl like this, it could be any bowl. You're also going to need, set this up right here. You're gonna need some saran wrap, some grains of uncooked rice, okay? You set this aside. You're gonna need some type of large spoon or ladle, and a metal, baking sheet. This is a cupcake tray. That'll work just fine. Anything that's made out of metal will do just fine. Okay, so what you're gonna do is you're going to first is wrap your bowl in saran wrap. So let me do that right now. And this is probably the most important part. You got to make sure that the saran wrap is tightly sealing the top of your bowl. And then what you're going to do, let me make sure that's pretty tight. And then what you're going to do is you're going to grab your uncooked rice. So your uncooked rice, and you're going to just pour a few grains over the top of the saran wrap. And then what you're going to do is you're going to get a little noisy. So make sure you have your parents' permission to get noisy. So what we're going to do is we're going to create some vibrations, and I'm going to kind of scooch this a little bit more towards the center. So what you're going to do is you're going to make sound. Now, what I'm going to do to make that sound is I'm going to hit this metal tray with my spoon, with my ladle, and I'm not going to touch this, but what you should see is you should see this this rice jump because the sound energy is traveling through the air. Those vibrations are moving through the air and are going to hit my rice. So let's see if it works. All right, so I'm gonna move it pretty close to the rice to make sure that I see something. So let's see. All right, did you guys see anything move? I saw a couple of grains of rice move. Let's try it one more time. That was a pretty noisy demonstration, wasn't it? And sound can get pretty loud, and unfortunately, loud sounds can be pretty harmful to our hearing health. When sound is harmful to our hearing health, and there's a lot of it coming from different sources, it's called noise pollution. What you're about to see is someone measuring sound in different areas of New York City using a decibel meter to check whether or not those areas are too loud and possibly harmful to our hearing health. Some of the following sounds you're about to hear are not harmful to your health, and in my opinion, are quite pleasant. These are some of the sounds you'll hear at our center, and hopefully you guys get to visit us soon. so you guys can experience them for yourself. Enjoy.
Wait. Remember what I was talking about, mosquito fish? Yeah. No, this is a tadpole.
Oh, cool. Oh, guys, I want to see a tadpole.
All right, guys, I hope you enjoyed your virtual field trip today and learned a little something about sound. I hope you guys get to enjoy the sounds around our center pretty soon. Have a great day.
Thank you, Mr. Dominguez. Got a couple more questions to answer from students. What would we do without energy? So without light energy, you would not be able to see anything. Without sound energy, you would not be able to hear anything. And without any kind of energy at all, you would actually be dead. Your body needs energy to live, like to make your heart beat and your brain work. And if you had zero energy, you would not be able to do those things. And the other question was, could we send energy to outer space? Yes. For example, we have the International Space Station that has solar panels on it that collect solar energy, but then convert that to heat energy to keep the scientists inside the space station warm so they don't freeze to death out in space. So we can send energy to outer space. Thank you so much for joining us this afternoon. We appreciate you taking the time to learn about forms of energy with us. We hope you enjoyed this virtual field trip, and you can let us know whether you did or not by going to www.tiny.cc/pk-2 feedback and filling out a short feedback form for us. We hope to see you again in about 3 weeks during our next field trip for second graders. Have a great rest of your day, and we'll see you next time.